guys, welcome back to VT Geos Chat. We're here for our second episode. I promise things we're going to keep getting better, and it is getting better. We have a microphone this week, so yay us. I'm very excited about this. I'm joined this week by not one, but two students in the Department of Geosciences who were both part of a group for a recently published paper, so we're very excited to talk about that. I'm here with Nithesh Sadhasivam. I said that right?
Yes.
I got that right. And he works with Dr. Susanna Werth and Dr. Manoo Shirzaei. And I'm also joined by Jonathan Lucy, who is also working with Dr. Manoo Shirzaei and Dr. Susanna Werth. So thank you so much for being with us today. And they're going to talk to us about their paper. It's kind of an interesting paper because these two lovely people use applications of remote sensing for their research, but the paper that we're talking about is actually a policy paper that's looking at how we can adapt as people and set better policies in light of tragedies such as the Palisades wildfire, and it's specifically looking at policy in relation to urban wildfires. But these gentlemen have been working on the radar applications and the science side of this paper, so I'm very excited to talk about that. So why don't you go ahead and tell us about your paper?
So, the paper in question, as Rose stated, talks about the 2025 Palisades wildfire that occurred in Los Angeles, and a main, I would say, point of the paper is how we can improve policy and decisions to better adapt to these urban wildfires that we haven't really experienced as much as we would as, say, a wildland wildfire. So that's the main point of the paper, and there's also a national security sort of perspective, which is really interesting about the paper as well.
Okay. Can you tell us about, actually I'm a little curious about the national security perspective. Was there a big takeaway, or is that something that's classified and you can't tell me?
Well, it's there right in the paper.
It's obviously not classified because it is in the paper.
Yeah.
But there is, the topic is really interesting because when you look at natural hazards and you think of hurricanes, tornadoes, floods,
right.
They cannot really be induced with human action per se. However, when you look at a wildfire, especially an urban wildfire, they can easily be sort of instigated or started with human intervention. So
like arson.
Yeah.
Right.
So looking at that sort of perspective and how preparing for these, I guess, instances, these urban wildfires, and setting policies to better defend against them, can also defend ourselves against foreign adversaries that may want to enact harm to our
Well, that's amazing. I would actually never have thought of that, but that makes perfect sense. But I know that wasn't exactly what you two were doing for your contributions to this paper, so I'll go ahead and ask you more about the science behind the paper, because I know that's what you two were doing. So can you tell me about the radar applications, or the applications of remote sensing? What were you doing with your radar? How did you work on the study? What were you studying? What were you doing? Can you tell us about that?
So we both work on different applications of radar remote sensing per se. I more work on groundwater resources, and he does work on also water resilience with the radar applications. For LA fire work, the important aspect we looked into is using radar remote sensing to identify those buildings that got burnt or, let's say, damaged during this LA fires, especially Palisades. So that's what was the application that we used.
That's awesome. So that was. Can you tell me about your methods? Like, how are you using a computer code? Are you using, how are you doing this work? Are you looking at pictures?
So, I would say the part that of the paper that I was responsible for was the building footprint extraction. So, selecting the buildings that would be used in the study.
Okay.
So, for that part of the paper, I used the Microsoft Buildings dataset, and after extracting, so I had all of the buildings for the state of California, but obviously we don't want to conduct a study on all of the buildings
Right.
of California. So what we then did is I used a boundary that was created by the state of California for evacuation during the Palisades fire, and I essentially extracted all of the building footprints, or essentially the outlines of every building that were within that evacuation zone, so that when we wanted to investigate which buildings were destroyed, that we would just use buildings within that evacuation zone.
Right. Oh, that makes sense.
So, yeah, adding to that, so basically we use microwave remote sensing images for identifying the damaged buildings, or those buildings that got damaged during this LA fires. And microwave remote sensing, or sensors that we have in the satellites flying above us, that basically takes images repeatedly every 12 days. We use Sentinel-1 images. They're basically handled by ESA, European Space Agency, and so we use this before and after images of microwave remote sensing to identify those buildings that were standing there before the fire, and that literally got damaged because of the fires. So we use post and pre-images from radar sensor to identify those buildings using the technique that Jonathan was describing. So,
Awesome. So you're saying it's basically a big satellite orbiting the Earth, taking pictures as it goes.
oh yeah.
Mhm.
Oh, that's pretty cool. And you can see the groundwater with that.
Oh yeah, we can not, yeah, it's invisible to us. We can study groundwater, or we can quantify, monitor, model, and quantify the amount of groundwater storage we have with the sensors that are flying about us indirectly using the physics.
Mhm.
Oh, that's pretty cool. I can think of a lot of industries and research applications that would be very interested in that kind of
Oh yeah.
technique. I do have, is there anything else you want to talk about with the paper in particular? Because I do have a few questions, but I don't want to cut you off.
I don't have anything to add.
Okay.
Yeah.
Well,
It's
what
a
I
very
would
it's
like,
a very short paper.
Yeah, it's a very short and
Yeah.
direct
yeah.
paper.
That's
comment.
great.
Yeah.
That's great. We love those. So one thing I'm curious about, so we talk about the satellite, it's orbiting the Earth and it's taking pictures as we go. And I think the question that a lot of us are going to wonder, especially people like me who burn in the shade, is this safe?
While I am not a electrical engineer or a medical doctor, per the CDC, radar waves or microwave waves that these satellites use are non-ionizing, so they do not have enough energy to really affect our DNA and cause us any harm. Any harm that you would think that maybe a
Okay.
microwave in your home would. So yeah, they are non-ionizing and they are not harmful to us humans.
And I would imagine one satellite, even with a little bit of microwave radiation, which is not going to interact with us, I would imagine that is probably pretty dilute by the time it reaches the Earth anyway. The surface of the Earth. I got to imagine that we're not really being exposed to very much.
Oh
from
yeah,
it.
there are different components like atmosphere that, yeah, basically absorbs the energy or the signal, but as Jonathan said, it's non-ionizing radiation,
Okay.
and it does not cause any harm to us in ways like X-rays or gamma rays does.
Okay. Well, as someone who gets sunburned at night from the moonlight, I appreciate hearing that very much. So I'm going to go ahead and ask you, what do you think the strengths of the study are? But from a scientific perspective, what about the study is particularly strong?
I would say the policy recommendations, and also, like we said, the national security perspective, because I think for me, the national security perspective is very interesting because not many papers that deal with natural hazards or that deal with natural hazards really take this national security angle to the paper, which I think is really interesting. And
I've never seen it in a geoscience paper myself.
yeah,
so that's pretty neat.
So it's a pretty novel idea, in my opinion.
Yeah, because anyone can start a arson in an urban area, and for example in especially West Coast, like California, LA, we have been having this problem like always, like in every 5 years. We have some fires in the West Coast. And what's interesting about this particular comment that we worked on is that people know more about wildfires, and scientists have studied a lot about wildfires, their behavior, and we have already they have modeled how a wildfire behaves. But with urban fires, the interface between urban and wildfire. So urban area has lots of synthetic materials, wooden, and all those materials which acts differently than a wildfire.
Yeah.
So that's a difficult thing to study and model and predict the behavior of how the fire would spread. It's very difficult and it's challenging. So that's one important perspective we talk about in this comment, and we believe that it will help bring new findings or new investigations into predicting those kinds of behavior for urban fires.
Yeah, that's awesome. I'd say that's pretty novel to me. I've never heard of doing that before, but that's pretty awesome.
And to add on that,
yes.
Also, in the paper, it is also discussed that the amount of harmful chemicals such as arsenic and other heavy metals, their concentrations actually increased during this fire. So not only is there the hazard of your house burning down, but there is also the almost after effects of these heavy metals and dangerous chemicals being suspended into the air, and then you can potentially breathe them in.
Oh, that's scary.
Yeah, I mean, one, losing houses is one painful thing to be having, and also having this health effects. It's far more dangerous than what we see.
So can you track, I'm just curious, I don't know the limits of the radar, but can you see the contamination in the atmosphere? No? Okay.
Yeah.
Well.
No, so though the contaminants being measured were done through a different method with a different lab. So we are not experts on.
That's okay. Just being able to see groundwater using a flying camera is pretty cool. So I think that's still a win. What do you think are the limitations of this study? In what ways do you think, from a scientific perspective, with the work you were doing, what do you felt was limited? What do you wish you could have been able to do that you weren't able to do, either because of limitations of the radar or just limitations of time, or was there anything that you felt you wish you could have done more for?
Oh, definitely. A full-scale science paper would have been fantastic for both of us. Yeah, this is a comment which is like almost 3 pages. And at first it was a long paper, but because of the journal requirements and stuff, we had to remove a lot of things. But so I don't know how to think about the limitations.
I would say one thing that I wish we could have done is use a buildings data set that has more information about the buildings. So see if there's some sort of connection or correlation to the type of material that the buildings are made from, maybe the stories that the buildings are. So just if there's any information on the buildings, and if there is maybe a correlation between buildings that were damaged and the material they were made out of, would be I think interesting.
One important thing that we saw, but we could also go more in depth into it, is whenever California or West Coast does have wet years, high precipitation or more precipitation, and the following year we have some kind of fire events, because the vegetation grows during this wet period and it becomes fuel for fire when it dries out the next year after wet year. That's one connection that we saw that we could have further developed. But I think our team members who worked with us are already doing that.
Yeah.
We are not part of it.
Well, that's pretty awesome then. So maybe this was something that can be done in the future.
Oh, yes.
100%.
Well, that's awesome. So I was wondering, what would be, and that actually segues into the last question I had for you, which is what would be a logical next step for this research, particularly from your perspective in your lab, what you were doing, but also in general. And you mentioned this was a 3-page comment, which is just kind of like a shorter, informative paper. What do you think? Do you think there could be any plans to continue this research and have? I know that a comment is peer reviewed, so this is something that has been through peer review and is published. You can see our bonus episode if you're interested in the peer review process. So this comment has been peer reviewed, but it's a short paper that's meant to be a general introduction to a topic. Do you think that there is anything that could be a logical next step for further research, either from your lab or from other people, maybe someone watching this who's inspired to get into remote sensing applications, that could carry this topic forward?
Yeah, I would say there are a lot of possibilities on what we could do, even with microwave remote sensing. For example, we could even study contaminants or how the soil moisture or groundwater, how it basically, the dynamics of it after a fire event like that. There's a lot of possible ways. But,
I guess if we were to say logical step, one logical step that I would make after publishing this paper would be expanding to different sites, expanding to different events that have occurred in the past that if we can go to past remote sensing data sets and do similar analysis and see what other connections we can make between these events. So maybe not just in California, but also just other parts of the U.S. and the globe. So I would really expand the scope of the studies.
Just one thought that come to my mind was that I have read that or I've seen that in papers that like in wildfire, places that have been in fire has been subsiding a lot after the fire has happened in the aftermath of that, more than those other places around it. So I don't know if they have done that in similar urban fire scenarios where they could see from our perspective of our lab using microwave remote sensing to see if LA or those areas subside more aftermath this urban fires.
Yeah, that sounds pretty cool. So I guess that's a really good opportunity to say that, if you're interested, if any of our viewers are interested in applications of remote sensing, there are a lot of research opportunities in this, a lot of industry opportunities, and it sounds as if there's a logical next step for some research right here. So that's pretty good. Those are all the questions that I have for you today, but I want to say thank you again so much for being on this show. Great chatting with both of you. Great hearing about the work you've been doing and this paper. And so just want to say thank you to all our viewers. It's been great having you with us again. Stay tuned for our episode next week. And as always, stay lava.